So welcome to today's session for artificial intelligence. So what we are going to see today. So till now we have come across different types of searching techniques, including heuristics. When we are going to solve any problem in AI or using AI, the primary methodology that I have suggested for you is construct the entire space in terms of tree data structure. So that would be easy for us, because traversal would be very easy. Either tree or graph. As per our convention, we could able to construct the entire problem space in terms of graph or tree. That is the thing I am giving you in the focus. Today we will understand three games, and even if you already know about that, then that would be very easier. How can we construct the possibilities using the tree or graph? Could be able to fix up any methodology over there. So that's what we are trying to learn today. How many of you know this game? Othello. It's a game renamed after Shakespeare's novel, Othello. Anybody know about the strategy of this game? Any answers? Have you played already? No. Yes or no? Some responses. No, sir. Fine. So how to play this? That assume that black is from my end and white is from computer side, means who is going to, in this board, in this matrix, who is going to secure maximum number of their own coins. That's all. So that could be the representation here. You could able to see initially we have started with 2 as black and 2 as white. Finally, who is going to end with the maximum number of value, this one. So that represents the goal state. Okay. Here the goal state would be a numerical one. Please remember, it's a numerical one. Now, how this game will work actually? I have some projected squares, projected circles, right? I can choose these things to fill up the content. Actually, in the initial stages of this game, before it came for online, while we are going to work with some steel plates. So in those cases, I could not able to turn the plate where I don't have the opportunity. Okay, so here it won't be like that. Where you can fix up your coin, they are giving you 4 locations. That is the place only that you could able to start with. For example, now I am starting with this square. See that? So my color is changed, right? Now if I need to fill this to be on white, right? This white is going to turn into black. Now check this. So mine is black. Computer is playing with the white, right? So how to conquer? How to conquer? Now you are getting the strategy, right? I am fixing up here. So number of whites are increasing. Computer is playing like anything. You people can open up your mic and you can convey me the strategy also. So I am, where could I place? Okay, I am placing here. See, computer is playing much more faster. It's getting expanding its horizon. I am placing here. Does everybody could I able to understand the game? What I am playing? Right? So now my blacks are increasing. Why don't we keep it here? See, it's having its own strategy. Now I am doing generate and test. I'm not following any strategy. Do I have any strategy to play with that? Do I have any strategy to play with that? Right? See, I am occupying with. Even you can convert into CSP also, because within this time I have to complete. Or these many number of coins mandatorily I have to complete. Now you see the chances are growing when I'm playing with that. Right? Now I'm going to block this. See, this entire thing will convert into black. Okay, it's ready to occupy. Shall I keep this? Now, how to obtain the, or what could be the maximum chances to be played? So that could be a problem to be managed. So, if I'm going to keep this here, converted. So where could I keep to go for maximum? Shall I keep here? So it's occupying in a rapid fashion. So I need to block. I'm getting, see here, if I'm going to block, I will get 3 coins. Okay, if I'm going to block here, yes, I'm getting more. So where can I block to move further? So the chances are improving. Huh? If I'm going to keep here, that would be great, right? If I'm going to keep here, it will occupy 4. If I'm going to keep here, everything will be converted. See that the chances are improving. I have to block everything, right? And this could be the only chance. So now the board is filled, right? I have won the game. 47. I have conquered with my block, and white would be conquered by the system. So we could able to move with maximum number of even for players also. Sorry, even for a number of durations, size of the matrix, size of the sections, right? Even you can change the dimension also if you think further, right? So that's the way. Here, the conditions would be like this. Goal state will be who will be occupying maximum number of squares. Maximum number of squares, that is the count. Starting state, we have started with 2. When we will start with 0. Right? If I am going to minimize the size of the board, the number of chances can be predicted easily. If I am going to increase the size of the board, if I am going to decrease the size of the board, number of chances can be predicted very easily. I have some defined chances. If I am going to increase the number of squares, number of matrices, ultimately what will happen? I could not be able to come to a point where it can be the point of forecasting or prediction would be something tough, that's all. But I think you have come across a very good design technique in your dynamic programming. Through dynamic programming, I could able to map with a maximum number of answers. If I'm going for greedy, I will go for all the possibilities, but that will take much more time, right, compared to dynamic programming. So you can think of your own possibility that how can we, in 2 ways that you have to think. How can I increase my chances of winning? Second thing, how can we optimally reach the goal state if I'm going to plan it, right? So assume that you are creating a game. I think people who are interested to gamers will be there. For creating the game, you can create this game. I think nowadays you are having user-friendly, so many GUIs came for creating game creation. A very good platform is Unity 3D that will give you some more interesting things to do, right? So try to create an automated game. So that could be the basic task. So those who are interested to design games, please reach me. I'll guide you how to do that. How can we involve, very frank to say, analysis of algorithms in this work? That there lies our complete neural network could be implanted on those things to make it to win, right? So this is game one, right? So remember that. The one more reason why I'm talking about this game here is, here we are playing with a partial observation. I know where I could able to place my coins, but some of the projections are still hidden for me. Right? Only I know sufficient information. 50% informations I know. 50% informations I am on projection. That's what searching with a partial observation. That is a category where you need to work upon. Right? Okay. Well, it is going to be like this. What about this game? I think everyone will be trender on this, right? Tic Tac Toe. People will be playing in school, even while they are on travel, right? And I think this would be very much interesting. Here you could able to get with it, even for level. Play against your friend. Any friend is there online. No one is there, I think so. Okay. So computer started playing, right? And keeping it. I'm avoiding its chance, right? It's avoiding my chance. I am creating the chance for the system. Again, I am avoiding the chance. So that could be the case. I am forecasting it, but my forecasting is wrong. I am avoiding its chance. It had learned from me. Here you could able to move further. If I am going to keep in a position, what are all the rest of the positions that it may block? Now if I am going to keep here, that means on the right side of the cross, if I am going to keep, ultimately computer will come and keep the corresponding chance here only, left side of my cross, because that will be the case for winner, right? Suppose if I am going to keep here, at the right side of my O, ultimately what will happen? It will come and at the diagonal side, it will come and keep its next chance. So chances of winning will be already tabulated. What are all the unpredicted sections of this case? That is the major criteria. Okay, so if I'm going to keep a cross here, it will come and keep a cross here. If I'm going to keep here, it will come and keep here. Right? Place 1, I'm having a winning chance. Place 2, I'm having a winning chance. Place 4, I'm having a winning chance. So left side of 4, sorry, right side of 4, right side of X, and other places where I will get triple cross 1, 2, 3. If I am going to keep these places, that is downstairs of X and left side of, sorry, left side also the chances will come. So this is the place where I won't get any chance. Let us check. It is going for its winning chance. Now it is creating the chance for me to uh, make it to think, right? Make it to think. So automatically, as a human being, what we will do? We will be blocking this. We are not providing the chance. Already it had learned from me how to win. Now within these 3 sections, I am having what I will be thinking. I will be blocking a mark at the right side of X. So ultimately it will come and block my chance. Okay, if I'm going to put int mark here, I'm going to block its chance. I have blocked its chance. Now it is ready to block my chance. Now I am blocking its chance, right? So how it is playing? Here the dimension of the game is limited. On these cases, what are all the winning parameters that would be listed? It will filter the cases where we cannot able to move for the winning strategy. So among that, how we are dividing it, whether I am approaching that column first or system is approaching that column first. Okay, again here I am having partial information available for my searching. Right, what is the partial information available? The winning chances. Domain is limited, it is very easy for me to calculate with the winning chances. Right, so that would be the case. Next, third game that I think how many of you know about this game? I don't know. I think people from CBSE that you may have a work on this. Backgammon. Does anybody know how to play this game? Backgammon. Backgammon. Do we have any answers? Backgammon. Backgammon. So many pronunciations are there. First, understand how these games can be played. Right. Then you could be able to start playing even in online. You have I think freeboards.com, likewise some websites are there. People combine and play these games. First, you understand what is this game, because searching with the partial observation whether it would be worthful for this backgammon or not. If so, what are all the things that we need to concentrate? So this is a game that you need to understand first how they are playing, right? Please watch through.
Lexi.com presents How to Play Backgammon, an exclusive tutorial. In this video, we'll be talking about components, setup, objective, moving checkers, anchors and primes, hitting checkers, hit count, doubling cube, bear off, point system, and game types. We've got a lot to cover, so let's get started. Section 1. Components. Backgammon is a board game for 2 players. Each player has 2 dice and 15 checkers, and there's 1 doubling cube. The board is divided into 4 quadrants, 2 outer boards and 2 home boards. Each quadrant is divided into 6 points, making a total of 24 points. The vertical divider is called the bar, and the bear-off trays are located on the side of the board. Section 2. Setup. White player has 2 checkers on 24, the backmost checkers, 5 checkers on 13, the midpoint, 3 checkers on 8, and 5 checkers on 6. Blue's checkers are placed opposite of white's. White moves counterclockwise, and blue moves clockwise. Section 3. Objective. The objective of backgammon is to move all your checkers into your home board and then bear them off. It's only possible to bear off checkers when all of your checkers are in your home board. The first player to bear off all their checkers wins the game. Let's watch a game between white and blue. Section 4. Moving checkers. Both players start the game by rolling 1 die each. This is called the opening roll. Both players roll the number 2. If the same number is rolled in the opening, both players must make a reroll. Now white rolls 2 and blue rolls 3. The highest number wins the opening roll, so blue makes the first move using 3-2. She can either choose to combine the numbers and move 1 checker, or play the numbers separately and move 2 different checkers. Blue confirms the move by clicking on the dice. White rolls double 1. When a player rolls 2 identical numbers, it's called a double. Rolling a double will give you twice the numbers. Just like with a regular roll, white can choose to move 1 checker, or separate checkers like this, as long as all 4 numbers are used. There's no limit to how many checkers you can place on a point. Section 5. Anchors and primes. 2 or more checkers on a point is called an anchor. An opponent's checkers can move to your anchors as you're occupying these points. When anchors are placed next to each other, it's called a prime.
You can block your opponent's checkers by trapping them behind the prime. This prevents them from escaping, giving you an advantage in the race.
We've traveled forward in time, and now the position looks like this. White rolls 3-5. As you can see, white is now unable to move any of his backmost checkers as blue is occupying these points with a 4 prime. Instead, white chooses another move, which we'll talk about in the following section. Section 6. Hitting checkers. A single checker is called a blot. This checker can be hit if your opponent lands on it. In the current position, blue has 1 blot on white's 3-point and 2 blots in her outer board. In the previous section, white rolled 3-5. He decides to hit blue while at the same time making a valuable anchor in his home board. When a checker is hit, it must be placed on the bar. White confirms the move by clicking on the dice. Blue must now use her roll to enter her checker into white's home board before moving any other checkers. Blue rolls 1-3. Since white is occupying the 3-point, blue is forced to enter on the 1-point. A checker is entered by moving it to an open point in your opponent's home board. If blue rolled 6-3 and was unable to enter, often referred to as dancing, it would automatically end her turn.
The more anchors you make in your home board, the more difficult it is for your opponent to enter from the bar. The closer to home a checker is, the longer it has to travel to see it.
Okay, let's take a break and talk about pips. Section 7. Pip count. In the beginning of the game, both players have 167 pips. Pips is the number of points you need to move your checkers in order to bear off all of them. 2 checkers on a 24-point. Each checker on this point needs to move 24 pips to be borne off. 2 times 24 equals 48 pips. 5 checkers on 13. 5 times 13 equals 65 pips. 3 checkers on 8. 3 times 8 equals 24 pips. And 5 checkers on 6. 5 times 6 equals 30 pips. This makes the total of 167 pips. When a checker moves forward, the pip count decreases. When a checker is hit, the pip count increases. The player with the lowest pip count is ahead in the race. The pip count determines the optimal strategy to use in the game.
If you're ahead in the race, you want to avoid getting hit and bring the checkers home. If you're behind in the race, you want to try to hit a checker to secure race and leave the loose position.
Section 8. Double and cube. The game has now reached a point where blue has an advantage over white. She's ahead in the race, as you can tell by the lower pip count, and she's trapped white behind her prime. When you have an advantage in the game, you usually want to double your opponent. The cube must be offered when it's your turn and before rolling the dice. The points won in the game are multiplied by the level of the doubling cube. When the cube is first offered and taken, the level is raised from 1 to 2. The levels can only double up one step at a time. Winning a single game with a cube level on 2 will give you 2 points. Winning a gammon, which is 2 points, with a cube level of 4 will give you 8 points. Blue doubles white, and white now has 2 options: pass or take. If he passes, the game ends, and his opponent wins the number of points at the cube level. Passing an initial cube wins the opponent 1 point. Passing a redouble from 2 to 4 wins the opponent 2 points, and so on and so forth. White takes, thereby becoming the owner of the cube. The game continues, and both players now play on for the new higher stakes. Blue makes her roll. The situation has turned, and white now has a slight advantage in the game. Only the owner of the cube can make a redouble, which is what white decides to do. Blue takes, and they continue the game with even higher stakes. Section 9. Bear off. All of white's checkers are now inside his home board, allowing him to start bearing off. White rolls 6-6 and bears off blue checkers from the 6-point. Blue rolls 3-5 and moves his checkers. White rolls 6-2. Since he no longer has any checkers on the 6-point, he must use the 6 to bear off the backmost checker, which is on his 5-point. The 2 can be moved with any of these checkers. But since backgammon is a racing game, it's a good idea to be greedy when bearing off, especially when there are no threats of being hit by your opponent. Section 10. Point system. These are the final seconds of the game between white and blue. White makes his final roll and bears off his last 2 checkers, thereby winning the game. There are 3 ways of winning a game of backgammon: single, gammon, and backgammon. A single 1 point is when you have borne off all your checkers and your opponent has borne off 1 to 14 checkers. A gammon 2 points is when you have borne off all your checkers and your opponent hasn't borne off any checkers. A backgammon 3 points is when you have borne off all of your checkers and your opponent hasn't borne off any checkers and still has 1 or more checkers on the bar or in your home board. In this example of white versus blue, the cube has a value of 4, as it was used twice during this game. White multiplies the 1 point from winning a single with the value of the cube. 1 times 4 equals 4 points, which is the final score of the game. Section 11. Game types. There are 2 types of games in backgammon: match play and money game. Match play is a series of connected games where you play to reach a certain score in order to find the final winner. For instance, you can agree to play to 5 points. The first player to reach 5 points wins the match. In match play, the Crawford rule applies. This means that once you only need a single point to win the match, the cube is not used in the game. Should your opponent get a point, the following game is post-Crawford and the cube is back in play. The money game is when you play one game at a time for an agreed stake per point with the final winner after each game. In money game, the Jacobi Rule applies. This means that you can only win a gammon or backgammon if the doubling cube has been used during the game. The Jacobi Rule is not used in match play. Practice your skills and become a better player for free at BackgammonGalaxy.com, the biggest backgammon site in the world. Analyze your games with the best AI. Play on your browser, tablet, or smartphone. BackgammonGalaxy.com. Play among the stars. Subscribe.
So that's the game. I think it will be something confusing for you, and you have to understand, right? I think you can take a paper and you can play the video again. So I have pasted the video link here as well as in the class group, third year CSCA. Okay, I have posted in your class group also. And I play this V Othello also, placing in your class group. So while you are going to draw, I think this will be given by Google itself. While you are going to draw, what are all the possible suggestions can be produced? What are all the possible recommendations can be produced? Always, we will be working for maximum function or minimum function. See, if the game is something on things to reduce, that is what minimum function. Maximum function means that you are moving forward for highest value. Always maximum function based games will check for numerical values only. Minimum function based games will work with more on search strategies. So that is the way that we have to divide. So whatever the game it has been given or whatever the problem has been given, first you have to identify the problem or game. Either it has to be approached in the maximum based one or minimum based one. Once if we understand that, then we could able to apply either, if it is maximum means numerical standard, if it is a minimum means we have to move for the search based one. And one more point I want to convey here is, based upon my experience, I'll be telling you that the content which are moving for minimum based one, there you have lot of chances for drawing your graph to obtain to reach from start state to goal state. But when you are going for maximum based one, you will be working more on maths to compute your next state value. Maximum based games, iterations will be more, but minimum based games where you could able to work with lesser number of iterations but possible number of traversals, either graph or tree, that has to be constrained here, right? So because as a CSP, when you are going to give more number of conditions, the process of pruning will be better. Pruning means cut down the unnecessary iterations, right? The pruning will be better. For that also we are having alpha beta algorithms available. So how to cut down the unnecessary iterations. So that's also the strategy. Okay. So these types of games will give us the idea how to construct our problem space, how to reach from problem space to solution space, how to construct array of solutions, right? So those things are necessary here. Okay, and I suggest everyone in this class that try to design a game and make that game to be involved with our AI stuff, right? So that could be an activity that I will integrate in your external learning one by Friday. That will be the best one. See, I'm not giving any deadline, but think over on that. Even the dimension, even if you want to create the same Othello, again do it, but with a limited number of dimension, right? So you have the pleasure of creating games as well as you can insert an AI domain. If you are very well versed in Python means, so you have the options to develop your game using Pygame. That is also possible. So many game stations are availing now free cloud account. Through that you can create and deploy games online that we could be able to go and play. The idea here is how the winning strategy, how the losing strategy, how the draw strategy are going to be fixed and blocked. So these three things are that all mathematics will get to binded with: max, min, neutral, right? Max, min, neutral. So you can make this problem based on integers. Integers means you have a negative end to positive end. Either you could be able to move purely on positive 0 to max. Either you can go for minimum max to 0, right? So how you are going to bringing down those strategies along with the thing, because initially people will be very interested in designing games UI, but logic must be incorporated from AI. Right? So that is the places where that we will be working with. So how adaptively that learning can happen? Stage one is using data structures and algorithms. We are preparing the solution set. That's all. But actually, what does that AI will ready to bring? You have to incorporate a learning function. How the opponent is playing, how we have to identify that path, or how to intercept that path, or how to deviate the path. These are all the levels of learning, right? That is the role of heuristic function in search strategy. Okay, that is the role of heuristic function in search strategy. So your understanding need to come in the steps. You must know how to design a game, how to incorporate data structures and algorithms, how to incorporate AI based one. Nothing but incorporating a learning function, right? So that can be divided into three levels: approaching for winning, identifying the opponent's style, third one learning from the opponent's style, right? Here you have a lot of complexities will come when you are going to work with your heuristic function. How my learning can be classified? How my learning can be classified? If my opponent player is playing well, no issues. If my opponent player is a beginner, it would be more advantageous for me because using my data structures I will win. There is no need to use AI if my player is a beginner. If my player is a professional person only, then I have to use my data structures plus AI. If my player is a moderate player, means either I can use data structure or AI, any one of them. Even I can go for hybrid mode also. Okay, so if you are ready to solve a solution based on time, means you are introducing the constraint. That's what CSP. That's what the idea. Constraint. Okay. So transformation of games need to be taken place in terms of constraints. So think about that. So that's the discussion for today. We have seen three games. How to play those games? How can you design those games? Right? So I have given you the uh, platforms where you can design. Think about that. How can you incorporate the algorithms within the game? So that's the place where you can move it forward. I suggest everyone best you can start with your tic-tac toe. So that's very easy for you to move forward for creating your solution set, for identifying the optimized solution from the solution set, depending upon the number of depending upon the uh, style of the player, level playing style of the player, right? Then you can come for Othello, then you can come for Backgammon. This could be your hierarchy tool, right? So that's the thing. Anything to clarify, you can ask. And yesterday, people have asked for materials. I will post it in Google Classroom shortly. Nothing to worry. Anything to convey? So start. Even if you have not solved your external learning activity, solve it. So I request all the students to post the complete roll number in the chat.